Hello everyone, today we shall discuss about the logic gates as well as the signals which is used. So we have two types of signal, that is analog signal and digital signal. As you all know, analog signals are continuous signal. It looks like this. Analog signal are the continuous signal, digital signal are discrete signal which is represented in this form. Troubleshooting of analog signals are difficult, where the troubleshooting of digital signals are very easy. Analog signals is usually in the form of sine wave, as I had said you before. A digital signal are in the form of square wave. As we know, analog signals are continuous signal. It is easily affected by a noise, where digital signals, these are stable and less prone to the noise. Analog signals use continuous values to represent the data. Digital signals use discrete value to represent the data. The accuracy of the analog signal may be affected by the noise, but accuracy of the digital signal are immune from the noise because the data will be sent in 0 or 1 form. So noise disturbance will be less in the digital signal. Analog signals may be affected during data transmission, but the digital signals are not affected during the data transmission. Analog signal use more power, digital signal uses less power. Example, analog signals temperature, pressure. Analog signals may be affected during the data transmission. As I had said you that analog signal has more power, uses more power. Example, temperature, pressure, flow measurements. Digital signals are not affected during the data transmission. Examples like wall feedback, motor start. The components like resistor, capacitor, inductor, diodes are used in analog circuits. Components like transistor, logic gates, microcontrollers are used in digital signal. These are the few differences. So this is a major difference between the analog and digital signal. So these are the few differences of analog and digital. So you can write any 5 differences when they ask you in the exam. So usually this question will be for 5 marks. So you can list out any 5 differences which you find it easy and you can write the answers for it. So next is about the logic gates. There are many gates, so we are going to study about the logic gates. So in the logic gates you have a basic gates and universal gates. Let us discuss what is basic gates, what is universal gates. Basic gates are OR gate, AND gate and NOT gate. You can see here OR gate. Usually you can write a OR gate for 2 inputs. Let me teach you. If it is 2 input, A and B are the input, Y will be the output. Input bits are 0, 0, 0, 1, 1, 0, 1, 1. OR gate means which performs addition operation. So 0, 1, 1 plus 0, 1, 1 plus 1, 1. So this is your OR gate truth table for 2 inputs. So let us discuss the logic symbol of this. So A and B are the input. So this is the symbol of OR gate. Y will be the output. So the similar way you have 3 input OR gate, that is A plus B plus C. A, B, C are the inputs. Output is Y. So same way you have a 4 inputs OR gate. So let us discuss 3 input OR gate. 0 plus 0 plus 0, 0, 0 plus 0 plus 1, 1, 0 plus 1 plus 0, it is 1, 1 plus 1, it is 1, 1 plus 0 plus 0, it is 1, 1 plus 0 plus 1, it is 1, 1 plus 1 plus 0, it is 1, 1 plus 1 plus 1, it is 1. So if they ask you the question to write the OR gate for 3 input bits, you are supposed to write this. If it is 2 input bits, you are supposed to write this table. You need to know one thing here: OR gates which performs the basic addition, so it does the operation of addition. Next is AND gate. What does the AND gate do? AND gate which performs the multiplication operation, and that multiplication is given by the dot symbol, A dot B. Here you can see the diagram of an OR gate. A and B are the input which is given. A and B are the input which is given, and Y is the Y is the output. Y is the output. So here, as I had said you, if the two AND gate is a logic circuit having two or more input or two or more input bits and one output bits, the output of a AND gate is high only when all of the inputs are high. In other case, the output will be low. So same way, you can see the table here for the 2 input AND gate. When both the inputs are low, it is 0, 0, 0, 0, 0, 1, 0, 1, 0, it is 0, 1 plus 1, it is 1. What it says, when all the inputs are high, the output will be high. Okay, this is about the AND gate. Things to remember here: AND gate which performs the multiplication operation and gives you the output. It can be 2 input or 3 input depending upon the question. You can answer it for 2 input bits or 3 input bits. The next is NOT gate. NOT gate which has 1 input and 1 output, which does the operation of complement. So if the input is low, output will be the high. If the input is high, output will be the low. So vice versa. You can see the diagram of the NOT gate here. So X is the input, output is X bar. Same way, X is the input, X bar is the output. So now we discussed about the basic gates, 3 basic gates: AND, OR and NOT. So if you had studied AND gate, NAND gate is just an adding a NOT gate to a NAND gate. It is just an opposite of AND gate. So just add NOT to the AND gate, that gives you the NAND gate. NAND stands for NOT AND. An AND gate followed by NOT circuit makes it a NAND gate. You can see in the diagram shown, there are 2 input NAND gate. NAND gate is obtained from the truth table of AND gate by complementing the output entry. The output of the NAND gate is 0 when all its input is 1. For all other input combination, the output logic is 1. So y is equal to A into B, complement of A into B. So you can see the diagram of the NAND gate. AB is an AND gate, adding a NOT symbol to it. So you can see in the diagram here. So 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. So this is all about your NAND gate. NOR gate. NOR gate stands for NOT OR. I repeat it, it is nothing but opposite of OR gate. So we are just adding a NOT symbol to an OR gate. So OR gate is followed by NOT circuit makes it a NOR gate. The truth table of a NOR gate is obtained from the truth table of OR gate complementing the output entries. So you can see the output of the NOR gate is 1 when all its input are logic 0. For all other input combination, the output is 0. The output of 2 input NOR gate expressed as y is equal to a plus b. Complement of y is equal to complement of a plus b. You can see in the diagram, this is a symbol of OR gate. We are just adding a NOT symbol to that. That gives you the NOT NOR gate. So we had studied NAND gate and NOR gate. Those two are the universal gates. So the next gate is exclusive OR gate. So exclusive OR gate means, again it has two inputs. You can see the output of the XOR gate is 1 when the inputs are unlikely, the inputs are unlike, and logic is 0 when inputs are like. So I repeat it, if any one of the input is high, the output will be high. If any one of the input is high, output will be high. If both are same, the output will be 0. So you can see the diagram of the exclusive OR gate, and it is given by y is equal to a XOR b. This is a symbol of XOR gate. Okay, you can see here 0 0 0 0 1 1 1 0 1 1 1 0. So next is exclusive NOR gate. So exclusive NOR gate means it is a NOT of XOR gate. Okay, you can see the diagram. Same truth table, you are just complementing the output. Okay, so you can see there is a small 0. It is nothing but a NOT symbol which is being connected to the exclusive OR gate. So you can see in the OR gate, any one of the input is high, output was high. Here what it happens is, if it is opposite of that, if any both of the inputs are low, output will be high. If any both of the input is high, output will be high. Other than that, it will be 0. So I repeat the truth table, 0 0 it is 1, 0 1 it is 0, 1 0 it is 0, 1 1 it is 1. So this is all about your logic gates. So in this class, we studied the difference between the analog signal and a digital signals. That question might be asked for 5 marks. And next we studied the logic gates. Logic gates might be asked for 8 marks or 6 marks. So in the logic gates, we studied the basic gates, that is AND, NOT, OR, and NOT, OR. We studied the universal gates also, NAND and NOR. We studied exclusive OR and exclusive NOR gate. So by this, I'll end this session.